All right, welcome to Database Development Design Week 8. We are halfway through now, a little more than halfway through of our 15-week course. Uh, this lesson we're going to be going over today is called Normalization. Normalization is a formalized methodology for what we've already kind of been doing in class. In class, we've been learning uh, some rules about, why you need to do certain things in databases, why we need to break things in other classes, why we need to build new tables, how we can avoid things like duplication, those kind of things. But normalization is kind of the rule structure around that. So let's go ahead, let's pop over to our slide deck and talk about it, okay? So normalization, again, is a process of structuring a relational database to reduce data redundancy and improve data integrity. These are so much the important rules here. Data redundancy is bad. Okay, that's one of the cardinal sins. If you're in there as a student, I only want to see you listed once. I don't need your name listed in multiple tables. That's what we want you to be in one table. And improve data integrity. Data integrity is things that make sure that, hey, Main Street is not spelled 7 different ways. So we don't understand what it is. Because like I say, as a human, if I see Main Street STREET versus ST, I understand they're talking about the same thing. A computer will not recognize that. So again, the idea of normalization, it's a formal methodology to check the fields are in the right tables and to help determine whether you need additional tables. This is a formal methodology of everything we've already learned so far. Everything we've discussed, all the problems you're going to run into, this is what normalization does. It's a formal methodology to approach this. So let's look at the first example we have here. This is an example of problematic database to track employee assignments. We have a list of employees, and then we have jobs that have been given. So this could be, let's imagine these guys or these people are tech support people for an IT department. So these are the different jobs they've been given. So you see project number 1 with this company, 8 hours, it's been given to 105, so that's Susan. ABC promo is given to 101 and to 105, and that's Susan and John. So that's how it works here. So the things we want to look at is issues like update anomalies. A poorly designed relational database can lead to problems updating the data. Insertion problems. Can you easily insert data into the assignment table? What's the primary key? What do you need to store the information in a project that have an employee assigned? Modification problems. Are you introducing a possible inconsistent data due to repeated info? And we have some repeated info right here. You can see this right here. ABC promo. This is repeated info. And this is something we want to try to reduce if we can in a database. Now remember, just to keep in mind, I'm going to put this note up here. What we are dealing with at this point is still the OLTP databases. These transactional databases. These are the databases you normalize. These are the databases, I call them your cash register databases. They're the live updating ones. These are not your reporting. These are not your data warehousing databases or your OLAPs. Okay. OLAPs you actually denormalize. We won't get into that here. Just let you know that when I'm talking about normalizing data, I'm really talking about OLTP. I'm talking about transactional databases. Okay. And deletion problems. When an employee is done with an assignment, can you delete a record without losing other important information? These are things to consider within your normalization. So let's go to the next step. A corrected example is showing database here. So what we've done here is we have a project table now. So we've taken, let's go back here. So we had this right here. We had employees, project numbers, project names, contracts, da, da, da. So you see this project number, name, and contact idea. This is for these 2 lines here, this ABC promo, they're duplicating. We don't want that. We don't want duplicated data. So we put it here. So I have a project number, contact, all information's there. And then we have an assignment table. And this assignment table, if we're paying attention, is, if we were to draw some lines, let's go ahead and draw here. There we go. I'm going to draw a connection here and a connection here. Now, if we were to use crow's foot notation, you'd say right here, this is a one-to-many and a one-to-many. This is how we get away with the many-to-many by putting a little table here in the middle here. So anomalies have been addressed. There's no chance that we can put in ABC promo twice and maybe misspell it wrong. There's no more problem inserting data because all the components of our primary key are available and insert, and we remove the possibility of accidental data loss as a byproduct of deletion. So that's what this has done. It has removed a lot of those problems by creating this, what we call a lookup table or a mid table or an insertion table. So this is something we've already done. This is nothing new you haven't seen, but this is just, let's take a formalized approach to it, okay? So normalization, we have to worry about what's called functional dependencies. It's a way to describe the interdependence of attributes or fields or tables. It's a critical component of normalization, provides a more formal definition of the primary key, and helps explain the concept of a normalized table. It's used to discuss the forms of normalization. If I know the value for an attribute, I can uniquely tell you the value of some other attributes. That's the one thing we're looking at. And to kind of look at a way to describe the interdependency. There's an interdependency here. This lookup table in the middle depends on these tables being properly populated. It needs to know if I've got a 3, I need to be able to find a 3 in this table to tell me what I'm talking about. If I've got a 1001, I need to be able to look in this table and see a 1001. So this is the interdependency of these tables. And you have to keep the interdependency in mind when you design and make changes. Somebody says, oh, I need to add something. I need to add a field to the employee table, like, I don't know, years in service. You have to ask yourself, well, if I'm going to add this field, is it going to affect my other tables? In that case, it would not. So it's okay. You can do that. All right. So keep in mind functional dependencies. Functional dependency example, if you know the value of an employee's ID, I can tell you the associated name, like we just said. Each employee number functionally determines the employee's last name. So 1011 tells us that it's John Smith, So that basically employee ID is equal. Is this also true? The last name is equal to employee ID? Absolutely not. This is not true whatsoever because you can have more than one Smith. You could have more than one John Smith. It's not an uncommon name, and where I work, I work in, data science and Verizon. I end up with a lot of a lot of Indian names, a lot of Pakistani names that are very common over there. A lot of Rajas, that kind of stuff, Patels, and so it obviously can duplicate. So the employee ID tells you who this person is, without question. So if we have more than one John Smith, we'd have a separate employee ID for the second one. You'd know exactly which John Smith we're talking about. Okay. If you know the values, I cannot tell you the associated project number with certainty. Okay. Each employee's ID number does not functionally determine the project number. Okay. Well, that's makes sense. I mean, it wouldn't design anyway because an employee can be assigned to any project. That doesn't make any sense. Why you'd worry about that? Understanding functional dependencies and understanding classes and their relationship are two different approaches to figuring out intricacies of the problem you're trying to model. Okay, so you can look at the way we learned it earlier in the class, or we can look towards this. I personally highly recommend you start to learn about normalization. It's the better way. It's the more formalized mathematical approach to this in my mind. Okay. So primary keys are very important in normalization. And this, where I tell you that you didn't need primary keys, you don't need them. But if you start to get into normalization, primary keys are king. Okay. So let's not forget that. Okay. Once you have a row in a table, you know the value of the other fields in that row. If you give me the primary key, I can tell you, I can tell you what the other values, So if you know the employee ID of a unique row, I can tell you the last name and the first name. Primary key functionally determines all the other fields in the table. Okay. The primary key, like I said, your G number at the school, if you're one of my students, your G number determines if I can go into a table, I'm sure there's a table in admitting or, up in admissions that I've got your name, your address, your age, all the things about you, what's your current status on paying your classes, all that. Okay. So that's the idea, is that, keep in mind, I always say, think about primary keys as like your G number. Okay. Primary keys with multiple fields. What if we were to pair employee ID and last name as the primary key? A primary key has no subset of fields. There's also a key. It seems obvious to avoid, but also to lead information redundancy. You don't need to add extra fields if you don't have to. I really say, especially in this class, try to keep your primary key to a single column. Yes, a primary key with multiple columns is valid and it's useful in many cases, but I don't think you're going to find the use in this course where we're trying to still develop and design simple databases. Okay, primary key with multiple fields. In a one-to-many relationship, take the primary key from the table 1 and put it in the fields of the foreign key in the project table here, okay? So if we have a primary key of employee ID and last name, then we would have to have 2 foreign keys of employee ID and last name. Now, looking at this, this should scream something out to you. This should say, you know what? Why am I adding 2 columns here when I could get away with just 1 as an effective foreign key? And that's one of the reasons why unique ID numbers are so important to all this. It's not the greatest design. I'm just looking at this, and believe it or not, I'm actually reading these slides for the first time as I go through this. So a lot of my commentary is based on what I'm looking at. I'm not even reading some of the context and stuff. Just letting you know, here we are. We're kind of breaking one of the cardinal rules of let's keep the tables only to hold the information they need to hold. We don't need to hold more information twice because you're eating up memory you don't need to eat up. And I know memory is not as big a concern as it used to be, but it's a good design problem. And exponentially, when you start to get into databases like I use at work, we're talking about billions of rows. An extra column at a billion, that's a lot. It is. Okay, so in normalization, we have many forms. But the one you're going to hear the most is down here called the third normal. That is the kind of the gold standard again for, I'm going to write it down here if I can get a text box going here. This is the OLTP gold standard, is the third normal form. And I want you to remember third normal form because this question, that term will probably pop up on an interview. They're going to want to know if you know third normal form. And you can just say this is for the OLTP design. If you go with an OLAP, which is a data warehouse, you're actually going to denormalize it. You're going to bring it back to the first normal form. But for now, let's just go ahead and take a look at the forms. But obviously, to get to the third normal form, you have to meet all the requirements, the first, the second, to the third. And we'll get into the requirements. Each of these levels of normalization build on a prior level. So a table cannot be second normal if it's not already first normal. A table cannot be third if it's not already second. Okay, so here we go. First normal form. Don't cram several pieces of data into a single field. Let's look at car interest right here. Career interest, I'm sorry. So we got a list of, hey, you've got students, and what kind of jobs might you want? Well, if you're like me or any other normal, person going through college, I didn't know what the hell I wanted to do at 18. I had no clue. I didn't know what I wanted to do at 25. I didn't learn what I wanted to do until I was 40, and I'm probably going to change my mind again by the time I'm 50. So what you're going to do here is let's look at these students, they've got, Jane Smith, she went nursing, developer, business. You got Robert, who's developer, finance, teacher. And you got James, who's teaching, business. So one of the ideas there, let's make sure that each one of these columns here is in its own column. Each one of these, comma delineated moments here, so it's in its own column. Because it's just hard to parse through this. You can put this in a database, and I've got plenty of examples in what I do for a living where this sits in a database. I'm dealing with one crisis right now on this, where I've got hundreds of this across in each field, and it's a real problem in parsing it out. So sometimes it's easier if what we do instead is we build a second table. So we have our table with our students here, and we get rid of that career interest table, and we go ahead and put a student interest table together. So I've got student ID 1, nursing, business development. And here we've got the primary. Now, personally, I'm not sure what's going to happen on the next slide. Again, I'm seeing these slides for the first time here. I would, if you're building this, just for your own sense, just my personal opinion, if you're building this in our class, I would create a, called a student interest key, you know, something like that, and just make that as like your primary key for this table. I would definitely make sure this table is a primary key. Just you can call it whatever you want. Just give it an auto incrementing number or an identity. All right, but there you go. We've solved this issue here by putting them into two different tables. Okay. Second normal form. Do not include additional fields in a key that are not needed to determine all the other non-key fields. What does that mean? Okay. Assume the primary key of the assignment table is employee project number. Is the assignment table in the first normal form? Yes. Do you need both employee and project number to determine the project name and contact fields? No, you don't. So what can we do? If the table is not in second normal form, remove the non-key fields that are not dependent on the whole. Are this dependent on the whole? That's what we got to think about here. So we remove it by creating a second project table. And these project tables are dependent on the whole. Jennings Ltd, that's their phone number. And that's their project number. Okay. ABC Promo, that's their phone. So they're dependent on this. You can't reduce one. Think of dependency. I mean, a great example, let's think about, just to kind of spitball off. I'm just going to make a new slide here. Okay. And let's think of something dependency here. Let's say we have a car model. Okay. Now, one car could be, we'll call it a Chevy Corvette. Now, if we know what a Chevy Corvette is, it's a sports car. It's been around forever, but it is a two-seater car. There are only two seats in that car. And that is a unique thing assigned to this. That's a dependency of a Chevy Corvette. You can't have a Chevy Corvette with more than two seats. It does not exist. The next thing we could go for is like, sorry, my the Honda Civic, okay? Small four-door car, could be two-door, but it is a four-seater at least. It could be five-seater if you have a kid in a small thing. But we call that a four-seater. That's part of the car. And you could go with, let's say, a Hyundai Santa Fe. That's a SUV, and it has a hatchback. You can open the hatchback up, and the hatchback is an identity of this car. These things are dependent upon the model. So you can look at the car model here as we'll call the car model the primary key. If I know this car model, I know these other things about it. These are dependent upon it. You can't have a Honda Civic that doesn't have at least seat four people. You can't have a Hyundai Santa Fe isn't an SUV, it doesn't have a hatchback. You can't have a Corvette that isn't a two-seater, isn't a sports car. So when we talk about dependency, that's the kind of thing we're talking about here. So removing non-key fields that aren't dependent, like a non-key field that wouldn't be dependent on this car could be like red. I mean, red has nothing to do with the Corvette. Anything can be red. So that would be non-dependent. You can move that to a color area. But that's the kind of thing to think about. So remove non-key fields that aren't dependent. Okay. At that point we move on. So that's second normal form. So second normal form is we've taken this right here, employee project number Jennings, and we said that these two together are not a good primary key. Let's try to keep the primary key singular. So now we've gone back to just have an employee project number, it's hours. So this is like a many to many lookup table. And now we've created another project table which separates. Okay, so that gets rid of the interdependence there. So now we step into the third normal form. Don't allow non-key fields to depend on a field that is not a primary key. So assume the primary key is ID. Is the employee table in the first normal form? Yes. Is the employee table in the second normal form? Yes. Can a value for department be determined by more than one field? Yes, marketing, department number, these different people, it's going to appear multiple times. And again, third normal. So, but do we know third normal already? Because do we know, looking at this alone, before we ever learned about third normal form, you see this marketing twice. That should tell you, hey, this really should. That should right there, you sit there and say, hey, you know what? I need to draw a line right here. I can get my pen to work here. Where's my drawing tools at? Bummer. Get this pen maybe? There we go. Should tell you right here. Let's cut a line right here. Now, it's not very much of a line, right? Not good at drawing. That should say, I've got a duplicate. The second I see a duplicate, that should say I'm not in a third normal form. I'm not normalized the way I want to be. Okay? So this should automatically become another table. And as we look here, it does become a normal table. So now we've hit third normal form. Remove the non-key fields, create another table. Department number will be the primary key for the table. Employee.department number will be a foreign key. And this right here is the way you look at it. This is a way of pointing out tables and their attributes they're at. Generally not used too much in databases, but that I don't like that writing right here. I'm going to say, don't write that down. Okay, so in summary, a poorly structured database can lead to update anomalies. You can have modification problems. The information is repeated. It'll become inconsistent. What we mean here, again, we go into find a text box, the old Main Street. My typing is something else. Main Street versus. Again, as humans, I look at both these, we know exactly what we're talking about, but the computer's going to see it as two different streets. Insertion problems. We don't have the information for each of the primary fields. We may not be able to enter a record properly. In deletion problems, we delete a record. We can remove a piece of information that another field can rely on. But when we break stuff up into proper tables that are not reliant on the other ones, then we can delete stuff without having to worry about blowing stuff like that. We worry about functional dependencies. If field A functionally determines field B, this means we know the value for A. I can uniquely tell you the value for B. If you give me your G number and I look it up, I can tell you your name. That's your functional ID. A primary key is a minimal set of fields that functionally determines the other fields. And for this class, I really want you to focus on primary key being a minimal set of fields. I'm just advising you to keep life simple and keep your primary key a single field. And if you have to, create a new ID field for your thing. It's okay. So the normal forms are the first. Don't cram several pieces of data into a single field. And if we go back and remember that one, it was, where are we at? Did I lose it? Sorry, I'm looking for no, that's not it. Hold on, we're getting there. That's it right here. So this is our first normal form. 1NF. Okay. And we want to make sure, cut off the commas. Okay. Second normal form, don't include additional fields in the key if they're not needed to determine all other non-key fields. All right. And that's the issue here where, what are we looking at here? We got the employee and project. It's the employee ID, the project ID. It's a mess. You really need to break this apart to only worry about the things that the project's assigned. The project's number should really only talk about these. That's all, because the project number is always, 3 is always going to be this ABC promo with this contact number. The hours are different. That's going to be based on what the employee and the job they do. But that's what you want to think about. And finally, we get down here, third normal form. Don't allow any non-key fields to depend on a field that's not a primary key. So if you a field that can be identified by any point in there that's not a primary key, that's an issue you've got. It's time to break it apart again. All right. You've already know how to do this. That's the main thing. We've already done this. We've done this with everything we've done so far by looking at it through a more just what's wrong with this and the problems we can develop. This is just the statements and the rules around it is your normalized forms. And we'll go deeper into this so it becomes more relevant. But it's just really good to know. And the most important thing to remember, all of this, and let me get my text box up again here, is that third normal form equals OLTP. Or, as I call OLTP, the cash register, because it is designed to just be a faster. And if you can't remember, it's online transactional, if I can spell right, processing. And you will go back and denormalize. And this is not part of our, this is outside of the scope of the course, but when you denormalized, you'll do that for the purpose of a OLAP, which is an online analytical processing. And this is designed for reporting, data warehousing. Okay. All right. Well, thank you very much. I look forward to seeing you in class again, and we'll discuss this some more. Like I said, we're going to still talk about normalization later, but that's really kind of enough to get us going. All right. Thank you very much. Can't wait to see you guys again.